is gently dropped from a height of 20 meters. So in what time it reaches the ground? So this is the ball from this level of, from this height of 20 meters, this ball is dropped. So this height is 20 meters and the velocity increases at a constant rate. Velocity increases at a constant rate of 10 meter per second square. That means acceleration is 10 meter per second square because it is simply dropped. So because it is simply dropped, its velocity is 0. So at the beginning you are just dropping it, so its initial velocity is 0, acceleration is known and displacement is known, and we know that the only equation that connects initial velocity, acceleration and displacement are s is equal to ut plus half a t square. In that u is 0, acceleration is 10 and the displacement is 20. Because acceleration is downward, it is minus 10. Displacement is also from the top to the bottom, so it takes place in the downward direction because final point is below, initial point is above, so this is also minus. So minus 20 equal to 0 plus half into minus 10 into t square. So minus 20 into 2, I'll just take one more step to do this. Minus 20 equal to minus 10 by 2 into t square because 0 is there. So both the sides are minus and minus will be cancelled. When I cross multiply 2 into 20, 40. So 40 equal to 10 t square, and when you cut 1 zeros, t square equal to 4 seconds, which means t is equal to 2 seconds. Plus or minus 2 will come. Time cannot be negative, so it is 2 seconds. So if a ball dropped from a height of 20 meters, it just takes 2 seconds to come to ground. And with what velocity it will strike the ground? Assuming that the initial velocity here is 0, and not assuming because we are just dropping it, the ball's initial velocity is 0 here. When it hits the ground, let us assume that the ball hits the ground here. At this point the velocity is v. You don't know what velocity is, so let us assume that velocity here is v. Initial velocity is 0 and final velocity we don't know, but the acceleration with which it is falling down is 10 meter per second square and the displacement is known. So all that is known, even time to strike the ground is also known. We have found out that is 2 seconds. So what is the velocity gained in 2 seconds? So the other equation, right? V equal to u plus at. V equal to u plus at. I'll just tell you why are we able to use all these equations, because this motion is uniformly accelerated. Because this motion is uniformly accelerated motion, we are able to use these equations. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. Only in such cases it will work. So the final velocity of strike you want to know here, with what velocity it strikes the ground. Initial velocity when it is dropped 0, acceleration is downward, so it is minus 10 into t. So the duration of striking the ground, that it is 2. So v equal to minus 2 into 10, 20 meter per second. It strikes the ground with the speed of 20 meter per second. It strikes the ground with a velocity of 20 meter per second downwards. That's how it should be said. So speed is 20 meter per second. With that it strikes. Velocity is 20 meter per second downwards. You see that because velocity is a vector quantity, I am just saying that downwards. I am adding direction information because velocity is a vector quantity.